Students, my screen was visible. It is visible. Students, screen is visible or no?
Okay.
Okay, okay. So today, good afternoon to everyone. Today my topic is lecture number 15, circle diagram. Okay, last class I have explained about the testing methods of three-phase induction motor. There are two testing methods are there. One is no load test, another one is block rotor test. Now by using these two tests, now we are going to construct the circle diagram of this three-phase induction motor. What is the purpose of this circle diagram means to perform, okay, to perform the operating characteristics in the entire structure. We are making this circle diagram. Definition: the locus diagram, once again, the locus diagram of such a current phasor is circular in nature, is known as circle diagram, is known as circle diagram. Okay, it is circle in nature. By using this circle diagram, all the performance characteristics of an induction motor like power factor, cos phi, efficiency, stator loss, rotor loss, maximum output, maximum torque, etc., can be predicted. Thus, a circle diagram, which is one of the graphical approach of predetermine the operating characteristics of induction motor. Okay, so it is the graphical approach. Okay, it is a graphical approach, as well as what is the shape of the circle diagram? It is circle. Okay, in nature. Okay, it is circle in nature. The data required to draw the circle diagram is obtained by conducting two tests. Okay, there are two tests we are going to perform by to draw the circle diagram. Okay, the first test will be no load test. Okay, no load test means we should not apply any load. Okay, the no load test is other name called as open circuit test. Okay, this is my first test. Second test will be blocked rotor test. The blocked rotor test is other name called as loaded test. It is also other name called as short circuit test. Okay, so by using these two tests, we are going to construct the circle diagram. Okay, we are going to construct the circle diagram. Okay, steps to draw the circle diagram. Okay, steps to draw the circle diagram. Circle diagram is basically horoscope of an induction motor. Horoscope means it will be show a nature, okay, nature of an induction, because all the parameters will be incorporated in the diagram itself. Okay, so by seeing the diagram, we came to know about the machine, it will be running in good condition or not. Okay, by seeing the circle diagram. Okay, it carries all the informations related to the motor and its performance parameters also. Okay, now in the no load test, there are three parameters which we are measuring it. Okay, one is v naught, another one is I naught. Okay, v naught, this is one first reading. Second one, I naught. Okay, second one is no load current. Third one is no load input power. So which instrument we have to use to measure the rated voltage? By using the voltmeter. Okay, to measure the current, ammeter, and to measure the power, we need wattmeter. Okay, we need wattmeter. So how many wattmeters we are using in no load test? There are two wattmeters, one for W1, another for W2. So therefore we will get W naught. Okay, therefore we will get W naught. And to measure the voltage, it is voltmeter. Okay, voltmeter. To measure the current, ammeter. Okay, like this in block rotor test also, instead of V naught, we are taking the short circuit because we are shorting the resistance there, because we are lock the rotor. Okay, the rotor not running it. So what happened when the rotor not running it? During the time, okay, during the time the machine, it is in standstill. Okay, so at that time we have to measure VSC. Okay, VSC we have to measure, and ISC, short circuit current. Another one is WSC. Okay, we know the equivalent circuit. Okay, in the rotor side, what is the rotor side equivalent circuit? X2 R2 RL, right? Okay, this is E2. Okay, this is E2. Okay, so no load test means you are not applying the load. Okay, the resistor value will be in 0 position. Okay, the resistor, it will be 0. So at that time we have to measure these parameters. Okay, so lock rotor test means what I am doing, we should not apply the load. So the circuit, it will be like this: X2 R2, the load is locked, right? It will be short circuit. Okay, it will be, we are taking one wire, we are shorting it, so automatically the current flows here only. Okay, it will be short. Okay, so this is the difference between equivalent circuit in no load test and block rotor test. Here also the same voltmeter, ammeter and wattmeter we are measuring. Okay, W1 plus W2. Okay, W1 plus W2. Okay, any doubt? Any doubt? The first step, we have to measure, we have to conduct no load test. Another one is block rotor test. Okay, so by seeing this no load test, once again, any doubts? Any doubts in this topic? Have any doubts, anyone? Can you please respond to me? Please respond to me.
Yes, sir.
Okay, can I proceed?
Yes, sir.
Okay, okay, fine. One second. Net is slow from my side. Then step 1. Okay, step 1. Okay, the first step, please note down, take a paper and write it. Step 1. The first step will be, take reference phasor V as vertical y axis. Okay, vertical y axis. We have to represent x and y. So first step, we have to represent phasor V in vertical y axis. Second step, draw x-axis. Okay, so we have to draw the x-axis. Now point 0 and y-axis, it will be the x-axis. Okay, this is my step 2. In step 3, we have to conduct no load test, calculate phi naught. Okay, calculate phi naught. So how to find a phi naught? How to find phi naught? We know W naught equal to root 3 V naught I naught cos phi naught. So phi naught we have to calculate it. So phi naught equal to cos inverse of W naught by root 3 into V naught I naught. Okay, one phi naught for conducting no load test, another phi naught for conducting blocked rotor test. Okay, that is phi SC. Okay, for no load test, what is the notation? Phi naught. Okay, for blocked rotor it is phi SC. Okay, it is phi SC. It is phi SC. Next one. Next one. Now draw the vector I naught lagging V by an angle phi naught. Okay, this is the line OO0. Okay, OO dash, OO dash. You see, I am drawing a line. Okay, I am drawing a line. Here we have to set 1 centimeter. Okay, we have to set in the scale, current scale, 1 centimeter equal to 5 ampere. Okay, this is the settings we have to mention it. Okay, by in your scale we have to mention 1 centimeter equal to 5 ampere. If it is 2 centimeter means it will be 10 ampere. Okay, like that we have to set their scale. Okay, this is one settings. Okay, this is the settings. Okay, next from O, now draw a line. Okay, draw a line. One second. I will change the settings. Wait. Okay, so O dash you mark at an angle of phi naught. Okay, phi naught will be 30 degree means you have to keep your protector here at the center point and mention the angle. Okay, and mention the angle. Okay, you have to mention the angle phi naught. Okay, and draw a straight line. Okay, yeah, draw a straight line. The I naught value which we are calculating from the readings, okay, from the experiment. So I naught will be 5 ampere means you have to draw 5 ampere. Okay, you have to draw 5 ampere. 0 to O dash, this is 5 ampere. Okay, how much 1 ampere? 5 ampere means 1 centimeter equal to 5 amperes. Okay, like that we have to set. Okay, then once you reach this 5 ampere, then you mark it as O dash, then draw a straight line. Okay, then draw a straight line. Draw a straight line. Everybody following my class? Boys, reply. Okay, then we have to measure ISN equal to ISC into V0 by VSC, where ISC is the short circuit current, V0 is the voltage, VSC is the short circuit voltage. This ISN will be the short circuit in normal current, ISN. Okay, short circuit current with a normal voltage which we are applying. Okay, then okay, so from O point again you have to keep and measure an angle of phi SC, then draw a straight line. Okay, then measure an angle phi SC, then draw a straight line of ISN. Okay, draw ISN. Okay, and mark a point of 5 ampere A, and mark A, and maybe this is 10. Okay, when you draw the circle diagram by using the values, then you will understand. These are the steps. Okay, I'm just giving the steps, you just follow these steps. Okay, and mark ISN, then join A to O dash. Okay, then join A to O dash. Once you join, then from O to A, you make it as off and draw a perpendicular bisector. Okay, a perpendicular bisector. Okay, perpendicular bisector line, and this bisector line which will be touch this O2 dash D line. Okay, then you mark it as C. Okay, then you mark it as C. Okay, then from C, okay, from C, keep your compass as a center in C and project at O dash, then draw a circle. Okay, then draw a circle. It's right. Okay, take C as center and O dash C as radius. Draw a circle, means it is a semicircle. Okay, it is half of the portion, it is semicircle. This circle should touch this A point. Okay, it should be touch the A point. Once it touch, then only you are understanding the circle. My circle diagram is very perfect. Okay, the performance characteristics in the machine, it is everything is perfect. Okay, the readings which you are taking in the laboratory is also perfect. Okay, then from A, okay, once the circle touch this A point, then you mark it as center, then draw a perpendicular line towards down, down to x-axis. Okay, from A, draw a perpendicular line to x-axis. It should be a straight line. Okay, it should be a straight line. Then this point, once this line, perpendicular line touches G, then you mark it as G. Okay, then you mark it as G. Okay, this line will be A to G. Okay, then the same line will be touch this F point, right? This point F. Okay, and this point will be marked as F. Okay, now there are two losses are available. Okay, one is stator copper loss, another one is rotor copper loss. Okay, A2 stator copper loss is 3 ISC square into R1. Rotor copper loss 3 ISC square into R1. Okay, these are the formula. Okay, rotor copper loss. But the rotor copper loss, this one, rotor copper losses that I will mention where you have to measure it. Okay, then from A to F, you have to mark it as center and project point E. Okay, then joint E to O dash. Then joint E to O dash. Okay, E to O dash. Are you understand? Okay, so once you join, okay, once you join, A to V will be the A to E is the, this portion is the rotor copper loss, and E to F will be the stator copper loss. F to G is the fixed loss. Okay, fixed loss. Okay, and this red color O to A is the output line, and O dash to E. Okay, this line O dash to E is the torque line. Okay, torque line, that is A to E. See what is the A to E? It is the rotor copper loss. E to F stator copper loss. F to G is the fixed loss, and O dash to A will be the output line. O dash to E torque line. O dash to E is the torque line. Okay, O dash to E is the torque line. Okay, the power scale which we are measuring in the circuit diagram will be power scale which I mentioned, the 5 centimeter equal to, that is at the starting state itself I mentioned 1 centimeter is equal to 5 ampere. 1 centimeter is equal to 5 ampere. 1 centimeter equal to 5 ampere. So to measure the short circuit power, WSN at normal voltage equal to WSC into V naught by VSC whole square. Okay, V naught by VSC whole square. Okay, these are the steps. Okay, then calculate of full load output equal to HP into 7, because 1 HP equal to 746 watts. Okay, so 746 into HP equal to watts. Okay, then okay, then we have to draw a W point from A to W and draw a perpendicular line towards the circle, down towards the circle, and the gap between the distance between this W to A, which should be same till this edge. Okay, so once this line, if you draw a trajectory perpendicular line towards down, and this point, once this line touches the circle, this point we have to mention L. Okay, this point we have to mention L. We have to mention L. Okay, from L again you have to project it down. L to K, you have to project it down. L to K. Okay, L to K you have to project it. Okay, so this L to K, it will be touch this red color line, output line, and this dark line it is touching, and this is touching the fixed line also, fixed loss line also. So we have to mention PQR, the symbol PQR. Okay, PQR. Okay, you have to mention the symbol PQR. Okay, you see, rotor copper loss is A to E, E to F is stator copper loss, and I1 is the, this one O to L, and O 0 to 0 dash will be the I0. I0 output line is A to O dash, and E to O dash will be the torque line. Okay, E to O dash is the torque line. These are the parameters which I am taking from the diagram. Okay, how to calculate the slip? You see, S equal to PQ by LQ. PQ means here, this one, PQ by LQ. Okay, you have to measure by using the scale, PQ by LQ, and power factor cos phi. Okay, because power factor, there are two power factor, one for load, no load test, another for block rotor test. Motor efficiency LP by LK into 100%. Rotor efficiency, rotor output by rotor input, LP by LQ into 100%. And starting torque, TST is equal to AE into power scale, because power scale is 1 centimeter is equal to 5 ampere. Okay, these are the last separations. Any doubts in the circle diagram? Any doubts? Any doubts in the circle diagram?